In this video, we are going to discuss the semester test 1 feedback. The questions won't be exactly the same as what you had on ClickUp because everyone got a different variation, but the concepts are still exactly the same. So let's get going. Now, for the first question, we said that the SEK 110 team decided to compare the heights in centimeters. So let's just highlight that, of a random sample of 20 Western Cape students. So here we have 20 and equal to 20, and a random sample of 36 Northern Cape students. So let's just write there n equals to 36. So we've done this with a stem and leaf diagram, but you can see for the Western Cape, we haven't actually shown you the values. We have hidden them, and we're just showing you the shape of that distribution. Now, we've also given you some descriptive measures, which means that you don't need to go calculate these yourself, but if you do, you should be getting to the same answers as we did. So first thing we ask you here is either whether you are, we might ask you what your variable is, and then we'll look at the other option just now. So our variable under consideration in this case is the thing that we are analyzing, and the thing we are analyzing is the heights of the student. So we're interested in comparing heights. So correct answer here would have been heights. Now, in another variation, you might have been asked to tell us what the elements are. And the elements, remember, are where we are getting our information from. So who are we questioning or observing to get our information? And that would be the STK 110 students, but specifically, you can see in this one, I've just given you a different data set. Here we had KwaZulu-Natal and Northwest. So we would be observing the students from KwaZulu-Natal and Northwest. So let's say for the previous one, it would have been the students from the Western Cape and the Northern Cape that we were interested in. Now, next part of the question, we asked you, or we gave you a scenario, and we said, let's say there are 26 students from a certain town in the Western Cape in our population, and we want to sample 20 of them. So what method should we be using? Now, if we're looking at this question, we can see it doesn't matter in which order we choose these 20 people. So we are going to use a combination. So our answer would have been taking a combination of 20 of the 26 students. And that would lead us to an answer here of 230, 230. Now, if we had said that we're selecting these people, and the first one we select will be the mayor, and the second one will be the secretary, and things like that, so there's a role assigned to each selection, then order would matter. But here, we don't care about the order. We just care about, we want to select 20 people out of the 26. Now, the next question, we are asking you specifically about the Northern Cape. So all of these questions were based on the Northern Cape data. So that's all I'm showing you at the moment. Now, the first bit is we need to calculate our median. And the median is the value exactly in the middle. If we use our percentile function, we could have calculated I equal to, and that would give us our position. So that would have been 0.5 times n plus 1, which is 37. So that gives me position 18.5 for the mean. Oh, sorry, for the median. So if we go to position 18.5, so if we go and count, you'll find that the value over here is in position 18. This is position 19. We need to take the average of these two values, which, lucky for us, is exactly the same. So these values are exactly the same, so we don't need to even do any extra math. So when we read this off, remember our leaf units would be 1, and on that original slide we told you that we're working in centimeters. So a leaf unit is 1 centimeters. So if we read this off, this is 160 centimeters in the stem, and the leaf would be 6 centimeters. So this is 166 centimeters. Then next we need to go and find the shape of this distribution. So for that, we need to compare the mode, the median, and the mean. So we already know what our median is. Our mean is given down here. So we can already see that the mean is larger than the median. And if you go look here, you'll notice the value that occurs the most is 155. So our mode, we can just go right here on the side, our mode is equal to 155 centimeters. So we know that the mode is the smallest, then the median, then the mean. So we can go and look between our options at that. So obviously that means that it's not this option, not that one, not that last one. We know the mode is not the largest, so we can eliminate all of those options. So we are left with one of these choices. Now we know that if we have the mean larger than the median, it means that we have larger values that are pulling the mean towards them. So our data is skewed to the right. So that would obviously be wrong, and skewed to the left would be wrong as well. So our correct choice here would be this option. Now, it would have been in a different order for you, so don't rely on it being the second last one. It would have been somewhere in that list. You could also look at this graph to see that it's skewed to the right. Our lowest values are at the top, so if you wanted to tilt this, you would tilt it anti-clockwise, and you would then see that this gives us a graph which is skewed to the right. So our next question asks us to calculate a percentile. We want the 90th percentile. So again, we are going to first go calculate the position of our percentile. So in this case, it would be 0.9 times 37. Because remember, in our formula that we're using here, we're using n plus 1. So in school, you might have used that p over 100 times n. That is not the formula that your textbook uses, so we're not going to use times n, we are using times n plus 1. Let's just put that in brackets for safety. So if you do that calculation, you're going to get 33.3. Now when you go look for your value in position 33, you will find that it is the value over here. So we know we need to take that value, which is 198 centimeters, and we need to add to that 0.3 because of this decimal. So our decimal here is 0.3 of the difference between the values in position 33 and 34. So that would have been 206 minus 198. And if we do that calculation, we end up with an answer of 200.4. Now, let me just double check that. Yes, so 200.4. So, biggest thing to remember is don't use the formula from school. Use the one that we've given you in your textbook. Now, the last thing that we wanted to know here was the upper limit for outliers for the Northern Cape students. And here the shape plays a very important role. So because we've said it's skewed to the right, we're not going to use z-scores to find that upper limit. We are going to use our interquartile range rule. So that for the upper limit would mean that we want to take Q3 plus 1.5 times Q3 minus Q1. And if I do that calculation, we've given you these values already. You didn't have to go work them out yourself. It's 178.25 plus 1.5 times 178.25 minus 156.25. So if we do that calculation, we end up with an upper limit of 211.25. Now, in the instructions, we did tell you that if you need to round, you should be rounding to 4 decimal places. So since this value only has 2 decimal places, you would give it exactly as calculated. If you add zeros, it doesn't make any difference. You don't have to add zeros when you type it in on numbers. Both will be acceptable. So don't worry about the extra zeros. Now, our next question, we told you that the distribution of Western Cape students is considered as bell-shaped with this mean and this standard deviation. So we're going to use this mean and standard deviation to estimate our population mean and standard deviation. But whenever you see a question where we have this assumption that we are dealing with bell-shaped data, you can immediately go fill in your values on this bell-shaped graph. So you'll see how that's going to help us just now. So first thing I'm going to do is I'm going to write my x-bar value here. My mean is 176. Then I'm going to go calculate the mean plus 1 standard deviation. And I find that that is 184.4. My value 2 standard deviations above the mean is 192.8. And 3 standard deviations above the mean is 201.2. Now, if we do it on the other side as well, we will get that a value 1 standard deviation below the mean is 167.6. 2 standard deviations below the mean is 159.2. And 3 standard deviations below the mean is 150.8. So we have all of our values here now. And now if we want to answer questions about this, you're going to see how quick it is when you have that sketch in mind. So our first question was, for the Western Cape residents or students, an outlier is a value bigger than what? Now, since we're dealing with bell-shaped data, we're not going to use that IQR rule. We are going to use the 3 standard deviations from the mean rule. And if you look at our sketch, we already know what that answer is. It's 201.2. So by just doing this sketch, quickly filling in those values beforehand, you already can see your answer. Then we asked you in the next question, the approximate percentage of Western Cape students' heights that are expected to be between 159.2. So if we look here, we can see that that's on our sketch. This value is 2 standard deviations below my mean. And 184.4, that value is 1 standard deviation above my mean. So all I need to do is I need to go and add up these percentages. Now, I didn't speak about this earlier, but if you go back to the empirical rule tells us that within 1 standard deviation of the mean, we expect roughly 68% of our values, which means that if we go split this in half, we're going to get 34%, 34%. If you look at 2 standard deviations from the mean, it's 95% of my values, which means that I could split it in 2, and that would give me the sum of these 2 values. So that would be 47.5% of our values within 2 standard, one standard, if we go from the mean to 2 standard deviations below the mean, or if we went from the mean to 2 standard deviations above the mean, because we have that symmetry. Now, in this case, if we've drawn this sketch and we quickly fill in these percentages, we can just go and add them up. And that will give us a final answer here of 81.5%. Now, the last question here, we have asked you for the 97.5th percentile. And that, remember, just means that 97.5% of our values will be less than this percentile that we're interested in. So if we go and add these up, you'll see that up to the mean, we have 50%. So up to 1 standard deviation above the mean, we're going to get 84%. And then if we add this 13.5%, it means that this value here is P97.5. So our answer here is 192.8. Now, some of you used the rule, the more technically correct rule, that within 3 standard deviations of the mean, you have 99.7% of your values. Since your textbook is using 100%, it's perfectly fine for you to just say, we expect pretty much 100% within 3 standard deviations. So that would be fine as well. Now, the next part of the question, we are going back to both provinces, and here we are asking you about relative variation. Now, whenever you see relative variation, you should start thinking of the coefficient of variation, which is just your standard deviation divided by your mean multiplied by 100, which of course gives us an answer, which is a percentage. So there's your second clue. There was a percentage written there already. So for this question, we want to go calculate both of these coefficients of variation. So let's say we start with the Northern Cape. So the Northern Cape, let's just write it as CV Northern Cape. We just use a subscript for that. I'll go and substitute in the value of S. So S for the Northern Cape is 17.63. Sorry for that. My pen sometimes does funny things. And then we need to divide by X bar, which is 169.33. And we need to remember to multiply by 100. So that gives us an answer here of 10.41%. Now we can go do the coefficient of variation for the Western Cape. And if we do that, it's going to be 8.4 divided by 176 times by 100. And that gives us 4.77%. And if we do look at this question again, we're asking you the relative variation in heights of the Northern Cape sample is what percentage more than the relative variation in heights of the Western Cape sample. So you just had to go calculate coefficient of variation for the Northern Cape minus the coefficient of variation for the Western Cape, and that would give you 10.41% minus 4.77%, and that answer would be 5.64%. Now, our next question, we can get to it, is again testing whether you know about comparisons between different provinces. So here I've used Free State and Mpumalanga. So let's say we're only interested in comparing people in this specific height category. So people between 1.9 and 2 meters tall. Now, if you look at this, your first important thing to notice is that our sample sizes are different for these two provinces. And the moment you see that, you should realize that you cannot directly compare these frequencies with each other because we don't have the same number of people in each of these provinces. So we want to convert these frequencies to relative frequencies. If we do that for the the Free State, we get that this is roughly 25% of our people in the Free State are in that height category. When Mpumalanga, it's actually just 12.5% of the people, which means that percentage-wise, we actually have a larger proportion of our people in the Free State who are in this height category. So more students from the Free State than from Mpumalanga tend to be in that height group. So takeaway message, whenever two groups have different sizes, you cannot directly compare frequencies. You can only compare relative frequencies there. Now let's move on to question 2. So question 2 gave you a bar chart for the modes of transport for first year students. You can see we have data here from 2016 to 2019. And you can see whether the students prefer to drive by car or ride a bike to class. So the first option that you could have had here is to ask you for the measurement scale. So again, think back to your original data. So we would have asked the student, what is your preferred mode of transport? And they would have answered us one of these two things. So when we're looking at the raw data, all our responses would have been either drive by car or ride a bike. And those are qualitative, and our measurement scale specifically would be nominal. So there's no clear order to this. It's just two categories. Our mode of transport for first year students from 2018 to 2019. So this is across different time periods that we've done this. It's not just at one point in time. So that makes it time series data. If we only looked at, for instance, 2019, that would have been cross-sectional data. Next, we asked you to identify whether different statements are descriptive or inferential. So there were quite a few statements available to you. So one option here would have been if we asked you for or gave you this statement: based on the results of the preferred mode of transport for first-year students for 2019, the preferred mode of transport of all first-year students for 2020 is predicted to be driving a car. So we are using the data from 2019 to say something about the 2020 students who we haven't observed, and that makes this an inferential statement. Now, if we look at the next one, based on the results of the preferred mode of transport for first-year students for 2019, the XTK team noted that 70% of the surveyed, notice here these are observed people, so 70% of these observed students preferred to drive by car. So no inference is being made. This is purely descriptive because we're not expanding this to someone we didn't observe. Then next, question 3, we gave you different sample sizes, different data sets, but the approach for a question like this, an Excel type question, would be to first look at what all the formulas give us. So you can see here, in the story, we've told you that we're observing 480 students, and each of them were asked how many language they speak fluently. So if we look at the formula worksheet, you can see that our options are 1 to 4. So let's say everyone spoke at least one language, but at most 4 languages. And we've only shown you the first 8 responses. So there's a lot more, obviously, because we've said that there's 480 in total. So you cannot go and figure out what's going on in column A. You can't go and do this in Excel. You have to use your knowledge of Excel to answer this question. Now, the first bit here tells us that we're working with the COUNTIF function. And we would go and count in column A. And what we would count in this first cell would be what we have here in cell C2. So this first value, when we look at the value sheet, will be how many people speak one language only. Here, in the second bit, in cell D3, we are looking at how many people speak 2 languages. And then 3 languages in the next one, 4 languages in the next one. So these are our frequencies. So you can call this maybe F1, F2, F3, F4, and this is the sum of all of these values, so that is my sample size. Now the next column takes firstly D2, which is my frequency for the number of people who speak one language, and it divides it by the sample size, times it by 100. So this means that here I have my percentage frequencies in this column. So you'll see the same calculation is repeated everywhere. Then next we have in the cell D2, which is again my frequency in that first category, divided by my sample size. So that's a relative frequency. But then the next one, you'll see that we take the answer from F2 and we add to it the next frequency divided by n. So that means that these are my cumulative frequencies. So let's write this cumulative relative frequencies that we have in that column. So now that we know what's going on, we can go do our calculations. But first you had a question asking you about the data type. So data type in this case is quantitative. And please go check your spelling when you answer these questions. We cannot account for every possible spelling error that you guys can make beforehand, which might mean that something gets marked wrong. Please go check that you are spelling things correctly. Now, if we go back to this, we've said here, these are our percentage frequencies, and here we have cumulative. So we're going to use that knowledge in a moment. So when you look at your values sheet, you'll see that we've given you some values, we've hidden a few, but we want you to answer a few of the others. So the first thing you need to go and calculate here is the number of students who speak 2 languages. And if you look here, you can see that if we look at the percentages, it's 56.04. So if we want to go answer that first question, we would take 56.04% and multiply that by 480. So again, notice our sample size is here as well. Now, if you do that a calculation, you're going to end up with an answer equal to 268.992. But you should immediately realize as well that this value here is a rounded off value, because it's not possible to have 268.992 students. You can't have a frequency which has a decimal value. So this must have been a rounded percentage, which means that when we answer this question, we actually want to go and round this off to the nearest integer, because we can't have a frequency which is not an integer. So we were looking specifically to see whether you guys realize that. So always think about your answer. Does it make sense to have decimals or doesn't it? So keep that in mind. Now the next part of the question, you had to fill in this first gap here. So when you look at your formula, how we would calculate that is we would take the value in D4. So I'm going to circle D4. There we go. I'll not circle it. I'll draw a block around it. We need to divide that by 480. Then we need to add it to what we have in F3. So we've given you the calculation to do. You just had to do that calculation. So it would have been 0.81 plus 67 divided by 480. And that gives us an answer of roughly, let's just make it approximate to 4 decimal places, 0.9496. So we can go fill that in here, 0.9496. And now the last one is our cumulative frequency at our last possible value that we can observe. So we know when we sum all of this, we get to 480. And when we sum or calculate this answer here in cell F5, it's actually just going to sum up to 1. Because cumulatively, when we get to our last option, everything should sum up to 1. So you didn't even have to do a calculation there. Now for question 4, we've given you 2 different box plots for a sample of students who did 2 tests in SDK 110. So for this question, we can assume that we had the same number of students doing both tests because they're all doing SDK 110. So let's start with the measurement scale. So measurement scale for this variable, firstly, we are observing test scores. So our measurement scale here would be ratio, because a ratio here would make sense. If someone got 2 marks and someone else got 4 marks, if you do a ratio of that, it makes sense to say the one person got double the marks of the other person. Now, and the 0, of course, means that you have nothing. You got no marks. Now, the next one, which test would you expect to have a lower standard deviation in test scores? And this is a typical insight question. So we didn't specifically discuss this with you, but if you understand how a box plot works and you understand how a standard deviation is calculated, you should be able to figure this out. So a standard deviation measures our average deviation from the mean. Let's write that out. So we're looking on average how far my values are from the mean. Now, if we say we have the same number of people writing both these tests, and you can see the spread looks very similar for these 2 box plots, you still need to consider something else. So here we have 50% of our values between 4 and 12. Here we have 50% of our values between 5.5 and 10. So you can see the middle 50% of our values for test 2 are not very spread out, where here the middle 50% of values are more spread out, which means that here this would already mean that we have a larger spread, so a larger standard deviation, where this bit would lead to us having a smaller standard deviation in our values. And that's pretty much it. So the correct answer here, the lowest standard deviation, would be for test 2. Now, in part C, we asked you which test has a greater percentage of students with scores above 8. 8 is our median in both cases. And here, even though the values for test 1 are more spread out, we still have the same number of people or the same percentage of people who are getting a mark above 8. So here, both of these tests have the same percentage of students who got 8 or more. The next bit, which test score distribution is skewed to the left? Now, if we look at this, you can see test 2 is skewed to the left. Let's just circle that. And that happens, we can see there's more symmetry here with test 1, but here you can see this box here on the right-hand side is a little bit smaller than the box here. This whisker on the right-hand side is smaller than the whisker on the left-hand side. So we are seeing more spread on the left than we are seeing on the right, and that tells us that it is skewed to the left. And then the last question, what percentage of students scored between approximately 4 and 12 in test 1? We've actually already answered that. So between 4 and 12 in test 1, we know it's the middle 50%. So 50% of our students were in that range. Now for question 5, we are getting to the probability questions now. So here we've given you a frequency distribution. We've split according to male and female, as well as the age categories for how old people were when they learned that Santa is not real. So our first question that we asked you is to calculate the probability that a student is male or learned that Santa is not real in the category 5 to 9. So I'm going to call male, let's just put an M there. I'm going to use that as a symbol, and I'm going to use this 5 to 9 as my symbol for the age group. So when I write this as a probability statement, I want to calculate the probability of a person being male if I randomly select them, and or remember is union, and we want 5 to 9. So that is what we are interested in here. Now, if we go back to our rules of probability, that tells us that we need to take the probability of male plus the probability of being in that category 5 to 9 minus the probability of finding a male and intersection with 5 to 9. So if we do that, I'm going to do all of this calculation in one go. All these probabilities would have been calculated by dividing by 1,600. So I'm just going to write that at the bottom instead of having to write that a few times. So let's go look at the frequencies for the males. Males, we know we have 1,120. Then we need to add the frequency here for 5 to 9, which is 736. But in doing this, we have added this intersection bit twice, so I need to remove it once. And if we do that calculation, you end up with 1408 over 1,600, which gives us a probability here of 0.88. And again, it says here round to 4 decimal places, but because you don't have more than 4 decimal places, you can give your answer exactly as it is. The next part, we asked you if a randomly chosen student is male. So when we do this probability, we've already told you that this person is male. And we want to calculate the probability that he learned that Santa is not real when he was older than 9. So we are combining these two groups, and I'm just going to call that my event. Let's make it A, for lack of originality. So we are asking, what is the probability of event A occurring given that the person is male? So to do this, we are just going to go calculate the sum of these two values here, so that the person is in these two categories. Remember, we're only observing the males here. So to make it easier, let's just go scratch this out. We are not interested in any of these values anymore because we have been given that we are dealing with the males. So we are only working with 1,120 people. And of those 1,120 people, you have 308 plus 168 in the categories 10 to 14, and 15 to 19. So if we do this calculation, we end up with 476 over 1120, and that leads us to a probability of 0.425. So that's how we would do this calculation. So the trick here was to recognize that we are working with a conditional probability. Now the next question, we said that we are using the event A for female. So I'm going to write the A here just to make it easier to remember. And B is the event that a student learned that Santa is not real in the age category 15 to 19. So I'm going to write that over there. Now, we're asking you to calculate the probability of the complement of A intersection B. Now, that just means we can use our complement rule. So this probability is actually just equal to 1 minus the probability of observing A intersection B. So that is the same as doing the complement of A and B at the same time. So that simplifies the question quite quickly. So A intersection B would be this value over here. So it is 24. Nothing is conditional, so we are dividing by 1,600. And that gives us an answer here of 0.985. And again, not necessary to add a 0 there. It's already to 4 decimal places. Now, the last thing was to calculate the sample standard deviation of the ages in years for group data, and we gave you a hint, use stats mode on your calculator. So you could have also jumped over to Excel and done it there, but if you weren't sure how to do it in stats mode on your calculator, what your approach would have been to be, first go and find your midpoints. So you would go on your calculator, set it up so that you can have X values and frequency, so you switch the frequency mode on, and then in your X column you would go and type the midpoints, because when we do a calculation for group data, we use the midpoints to estimate the average value within each interval. So then when we multiply it with the frequencies in each interval, you're actually getting a rough idea of the sum of the values in that interval. So that's the concept that we're trying to use here. Now, in this case, if we're looking at, let me just find the right answer here. So if we're looking at the standard deviation for question 5, sorry, I think I might have... there's my answer. Sorry, just got lost for a moment on my page, but I have found it again. So when we do this calculation, first thing you enter is your midpoints. Then you would go add the frequencies, and then you go, as usual, to your standard deviation button, which could look like an SX, or it could be, like on my calculator, it's called sigma n minus 1. So that is what it looks like on some of the calculators. But the idea is it is the sample standard deviation button. So just entering the midpoints and the frequencies will give you that answer. So what you should have entered here would have been 2, 7, 12, and 17. Those are your midpoints. And we want the sample standard deviation of the ages for all of the people. So we're just going to remove the genders here. We're not worried about the genders. All we're worried about are the totals. So those are the frequencies that you have to enter. And in this question, we are going to end up with the answer here of 4.5335. So if you're stuck on this, go and check whether you can get to this answer on your calculator. You can also go check if you can get to it using Excel. In this case, using the calculator is actually the faster method. Now, the next question was about an ogive. So an ogive gives us cumulative frequencies or cumulative percentage frequencies. So again, first thing you need to do is check what's on your graph. So we have cumulative percentage frequencies here. We are dealing with 240 people, and we again recorded the age at which they realized that Santa is not real. So the first question we have here is, we want to know the approximate number of students, and number, not percentage. So if you had read the percentage off and ended your answer there, it would have been wrong. Now, approximate number of students. First we find the percentage, then we convert to a number, and we're interested in the ages 2 and 5. So if we go here to the age 2, what we would do is we would read this off. So we would go from here up to this line and then across to here, and we find that we have a value over there. So roughly, sorry, let me just get back there, roughly over here. And that is approximately 3%. So at 2, we are going to find that we have 3% of our people who found out by the age of 2 that Santa is not real. Now we can do the same thing at the age of 5. We would read this off, and if we go across here, we find that that is equal to roughly 11%. So at the age of 5, we will find that it is 11%. So that means between these two ages, we're going to take the 11%, subtract from that the 3%, and that gives us 8%. And if we want to know then what the number is, we just need to take 8% of 240, which is the same as saying 0.08 times 240, and that gives us an answer of 19.2. But of course, you cannot have an answer of 19.2 exactly, because you can't have 19.2 people, so we're just going to round off to 19. But with this question, if you did give the 19.2, we would have accepted it as well. We did use a range of values because you could have looked at this and maybe thought, oh, this is 2% instead of 3%. So we did give some leeway there. The next question, we said the proportion of students who learn Santa is not real at an age of at least 8. So that means that we're interested in an age of 8 and older. That's what the at least part tells us. So if we go read this probability off at this percentage off at 8, we are going to find that this is roughly equal to 25% of our values. Now, if we are asking for at most 8, that would have been your answer, but at least 8 means greater than 8 or 8 included, which means that we need to now convert it and say 75%, because we're looking at the upper bit, not the lower bit. So then we need to answer this, but you would have noticed on numbers that it wasn't allowing you to type a percentage sign. So technically a proportion can be either a percentage or a relative frequency or a fraction. Since you can't type the percentage sign, you can't give your answer as a percentage. If you tried to type a fraction, it would have also given you some concerns there and told you you can't do that. So the correct answer here, acceptable answer, was to write 0.75. Then the next question, we asked you for the 69th percentile of age at which students learned that Santa is not real. So we need to go to 69%, which is over here. And if we go read that off all the way over here, you can see that this is roughly at 13 years of age. So if you had said 13.01 or something like that, that would have been acceptable as well. Now, the next question asked you about the mode. So the mode happens on an ogive. We know by definition, and this is another type of insight question, similar as what we had before when we asked you about the standard deviation with the box plots. You should be able to link all these concepts together. So if we ask you about the mode, first thing you think about, mode is the interval, or the modal interval is where we find the highest frequency. So let's just say highest frequency. And we can see which interval has the highest frequency by looking at the steepness of the curve. So if we look here, we can see there's not much of an increase from 0 to 4. there's a bit more of an increase between 0 and 8. Then there's a steep increase. There's a steep increase here again, and then not much of an increase. So if we have only one mode, it has to be one of these two. If it's possible that we have two as well. So what we would have done is we would have said, well, let's have a look at this value. At this point, we have roughly 95% of our values. At this point, if we read that off, that's about 60%, which means that in this interval, we have 35% of our observations. So let's check this one as well. At this point, we are at about 25%, which means that, again, the difference between these two would be 35%. So we do indeed have two modes or two modal intervals. So here, the lower limits for these modal intervals would have been 8 and 12. So that would have been your answer. Now the next question, we are looking at a scatter plot that you could go draw, but we're trying to see a linear relationship between two different variables. So we're looking at the relationship between the number of people sharing a device and the scores obtained in a practical test, and we're looking at 10 different people. So you could go into all of this data on your calculator to go and calculate the standard deviation. So again, it would have been in stats mode. You would have just entered all of this data. If you did this in Excel, you would have gotten the same answer again. So if you do this calculation, you just need to make sure that you use the sample standard deviation because we are working with sample data here. So when you do this calculation, the correct answer is 13.3687. Now, value of the covariance. Covariance does not have its own button on your calculator, but if you think about the formula for correlation, you'll see that covariance features in there. So we can calculate the correlation as the covariance divided by the standard deviation of x times the standard deviation of y. So if we want to rewrite this formula, we can say that the covariance is just the correlation multiplied by standard deviation of x multiplied by standard deviation of y. So we've already given you these values. You just had to calculate this one yourself. And if you did that calculation, you would have ended up with a covariance value of minus 20.6673. Now, when we want to do interpretations, the next one, we asked you about the interpretation for the correlation coefficient. If we had asked you about the interpretation for the covariance, covariance only tells us for a linear relationship if it is positive or negative. It does not tell us about the strength. So it doesn't matter what this value is, because that value is influenced by the units we use for x and y. So if you guys went and, for instance, just for an experiment, go and enter these values, but enter the y values, divide all of them by 10. So you would have had then 8.4, 5.5, and so on. Go into that and see what happens to your covariance. It should be 10 times smaller. So it's very dependent on the units that we're entering. Correlation, however, is a standardized measure. So correlation keeps in mind what the units are. It kind of cancels out the units. And when we calculate the correlation, we can now tell about the strength. So correlation tells us about strength of a relationship, and it tells us about direction. So is it positive, negative, or is it no relationship? So in this case, our correlation coefficient is quite large in the negative sense. The negative part tells us that we have a negative relationship. So immediately we can cross out those two. We know we have a negative one. And this is very close to -1, which means that it's a strong relationship. So as a reminder, you can go have a look at slide 18 of your chapter 3 class notes, the second set of notes. So you'll see it's called chapter 3 continued. That gives you some guidelines, but those guidelines will differ from website to website. Those are just the guidelines we're using for this course, but in practice you might use different guidelines as well, so just be aware of that. Now, question 8, we gave you quite a lot of information. So for a question like this, I always recommend that you write down all the given information so that when you get to answering your questions, you don't need to go search between all of these words. So we're going to read this and write the information down as we go. So the probability that a STK 110 student has access to uncapped data at home is 0.45. So we can see that we've called access to uncapped data at home. We've given that the symbol D. So we can write that down already, that probability. Now, the probability that internet connection at home is stable is 0.56. We've called internet connection at home stable. We've named that I. So probability of I is 0.56. Then the probability that a student's preferred task at home is to wash dishes is 0.3. Washing dishes is a W, so we are going to write that down. And then we've said there, given that a student has uncapped data at home, so given D, the probability that the internet connection is stable is 0.8. So this is the probability of I given D equal to 0.8. Then we've also added some extra information, and we've said there that stable internet connection is independent of preferred task at home. So I and W are independent. I'm just making a note of that as well. Now, the first question we ask you is, what is the that you need to calculate the probability of I union W? So again, we go back to our basics of probabilities and say, well, this is just the probability of I plus the probability of W minus the probability of I intersection W. And if we look here, we can see we have probability I, that's already available to us. We have probability D, so let's go write those down. This is 0.56 plus 0.3. And then we need to subtract the probability of the intersection here. So this is where our assumption comes in. I and W are independent, and because they are independent, this probability here can be calculated as probability I times probability W. So if we do that, we could just say 0.56 times 0.3, and that ends up giving us an answer of 0.692. So it's only because of the independence that we've given that we can do this calculation. Otherwise, we would have had to use a conditional probability multiplied by a marginal probability. Now, the next question, we want to calculate the probability of I intersection D. So probability of I intersection D, we are going back to basics here because we don't know anything about I and D being independent. And if we think about it, uncapped data at home and stable internet access is often linked to each other. So if you have uncapped, there's a good chance you have stable internet. If you don't have, if you have capped data, maybe it's stable, maybe not. If you're working off mobile data, it could be very unstable. So your type of data connection and your type of internet could be very much linked with how good that connection is. So let's go back to basics here. So probability of I intersection D can be found using two methods. So the first would be to go calculate probability I plus probability D minus probability I union D. So we have this, we have this, we have no idea what that probability is. So that one is not going to work. So next thing we can do is go back to our definition of conditional probabilities, and notice we have a conditional probability which includes an I and a D. So I'm going to write that one down. This is probability I given D. And if we had to calculate this from scratch, it would have been probability of I intersecting with D over probability of D. So it's always the given one that we're dividing by. So this value here we know we have, the probability D we have, and this is our unknown that we want to calculate. So we can just rewrite this as probability I intersection D is equal to probability I given D times probability D. And if we fill that in, this is 0.8 multiplied by 0.45, and that answer is going to be 0.36. And again, you can see we've just gone back to the basics. Now, the last question, events I and D, we've already said it makes logical sense that they're dependent, but let's go check that. If they are dependent, or for them to be independent, let's just write that down. So if they are independent, what we expect to see is that the probability of I given D is equal to probability of I. We could also go check if the probability of D given I is equal to probability D. We could check if the probability of I intersecting with D is equal to probability I multiplied by probability D. Now, if we look at our given information, it's always safest to use whatever is available to you in the easiest way possible, where you haven't done any calculations, so that if you did make a calculation error, it doesn't impact this answer. So if you look at these options, the last one, we have this, we don't have this one, we calculated it before, so it is an option to go and check it. The probability of D given I, we don't have that one, it's an unknown. We do have this one, so we're not going to use that rule either, but you can see we do have probability I given D, we have probability I, and we can see that they are different. So they're not the same, which means that we have dependence. So we can immediately go scratch out all of the independent ones, and then we just need to check our condition. So we've checked whether I given D is equal to I, and we have seen that they are not equal, so this one looks correct. This one is not something that we would ever check, and we also wouldn't go and check that one. So this is our correct option then. Now for question 9, we were working with a discrete probability distribution. So we said let X be the number of smart devices of a SEK 110 student, and we've given you this probability distribution. Then we've told you to calculate the probability that a student will have less than 3 smart devices. So that's a probability that X is less than 3. Always, always, always write down your probability statement so that you know what is included, what's excluded. It's just good practice, and you're much less likely to make mistakes. So if we do this, we know that we need to go up to and including 2, which means that it is 0.25 plus 0.36 plus 0.09. And if you do that calculation, you will find that your answer is 0.7. Now for the next question, calculate the probability that a student has at least 2 smart devices. So this is the probability that X at least means greater or equal to 2, which means that we can go and just add those values. So 0.09 is the probability that goes with 2, plus the one that goes with 3, which is 0.21, plus 0.09 again for the 4-bit. And that gives us an answer of 0.39. Then lastly, we asked you to calculate here the expected number of smart devices that a student has. And we know if we are dealing with the discrete probability distribution, the expected value of X is just going to be the sum of my X values, my different outcomes, multiplied by Fx. So again, you could have calculated this on Excel very easily, or you could have typed it in on your calculator, and either way would have given you the answer quite quickly. But the basic idea is we would want to say 0 times 0.25 plus 1 times 0.36, and we would have carried on like that until we got to the last value, and we would have said 4 times 0.09. If you do that calculation, you will get to an answer of 1.53. Then our last question deals with a binomial experiment. So we're going to go through each option and see if any of the binomial conditions are violated, and then we should end up with only one answer in the end. So our first scenario tells us a study showed that 85% of students have at least 2 smart devices. A questionnaire survey issued to 30 students. So we have an N here which is fixed, so we're happy about that. Asked if they have at least 2 smart devices, and then we say here, note that some students may be from the same household. So if you think about the number of devices that you have, it could be linked with what's happening in your household. So if we take siblings who live in the same household, let's say this is a family with a lot of resources, each person might have multiple devices. If you are a family that doesn't have access to a lot of resources, you might be lucky to have 1 device. So this means that we are not working with independent trials. So that one is violated. So let's just actually write it as not independent trials. And that actually means that that probability of 85% of students might not actually be the same in that household. So for students within a certain household, it might not stay the same. So not a fixed value of P. So that one is also violated. And you'll often find that if you don't have independent trials, you're also not working with a fixed value of P. Now the next one, it's known that 30% of students are not active on ClickUp. Students were asked what time of day, either morning or afternoon, they mostly access ClickUp. So if you think of a binomial trial, we are asking you to count the number of successes. We haven't specified in any way here what a success or a failure is. And we're actually just asking people what time of day are they most active on ClickUp. So we're going to be recording just morning or afternoon, but we're not really doing anything with it. So we don't have a binomial variable specified in this case. It's not known what the binomial variable is. Then the next one, it's known that 75% of the SDK students fail a test if they have to share a device. A student who shares a device was given up to 3 attempts. So notice immediately, up to. It's not a fixed number of attempts, and we are counting the number of times they failed the test. So maybe they'll do it once, maybe they'll do it 3 times, maybe they'll do it twice, maybe they'll just skip the test altogether. So in this case, we don't have not a fixed N. So we don't have a fixed number of trials. Okay, so let's look at the next one. Here we said, suppose that 1 out of every 18 students in Gauteng owns a car. 30 students, so we have a fixed N here, from Gauteng are randomly chosen. We have that independence, happy about that. And the number of those who own cars is observed. So we have our variable definition here as well. And you can see here this is fixed because we have that independence. This P is all good as well. So this one is looking very good. But just to be safe, make sure that we haven't missed something. Let's check the last one as well. So the last one we said, research has shown that 40% of students prefer mowing the lawn, 30% vacuuming the house, and the rest prefer washing dishes. We have 40 students. Again, N is fixed, so that one is fine. And we are asking them to indicate what their preferred household chore is. The number in each of the categories is noted. So we have 3 categories here. And we are recording the number of people in each of those 3 categories. So it's not just 2 outcomes. So with the previous one, you either have a car or you don't. So we have a success versus a failure. And here we have 3 outcomes. So we're not going to have a success and a failure only. So this one is definitely also not binomial. So we've said that's not, and that's not. So all of our binomial properties were met with this last one. So that means that is our binomial experiment. Now, that was everything for semester test 1. So takeaway message for you guys, just a few last pointers from our side. Please make sure when you are doing your tests that you submit regularly. Every time you type an answer, submit that part of the question so that you make sure that those answers reach the server in case there's any technical difficulties. If you submit an answer and you later change your mind, you can go and change your answer again. So also when you're doing your questions, please make sure that you read your questions properly, that you don't skip over something. Don't be in so much of a rush that you don't that you miss important information. You saw with question 1 how taking a minute or so to just quickly set up that picture with your empirical rule and write down those percentages, how that actually gave us all the answers already. So often if you just look at the information, you summarize all the information in the question that's been given, and you just calmly think about it, you won't miss the important details and you'll do much, much better in your test. So it's often a test is a leap of faith. You want to see whether you understand what you're doing. And if you leap in wholeheartedly and you believe in yourself, you are much more likely to do better as well. If you start doubting yourself during a test, you often scratch out the right answer. I can't tell you how many times we've seen it where a student goes and changes an answer because they started doubting themselves, and then it's the wrong answer in the end, and they originally had the right answer. So believe in yourself. If you've done the work, if you've put the effort in, you will be capable of doing the tests. So I hope the next test goes better than the first one. I hope it went well in the first one and the next one is even better.